This is a lesson on conditional probability. Conditional probability is the probability of an event given that another event has occurred. This is the formula of conditional probability. Probability of event A given that event B has occurred can be found by taking the probability of A intersects B and dividing it with the probability of B. This line represents the word given, and the conditional probability is read as probability of A given B. This formula is not hard to remember. Anything that we put at the back here, we put at the bottom of the formula. Also, please take note that sometimes the word if is used interchangeably with the word given, so the word if has the same meaning as the word given. Let's look at this example. To find probability, the first thing that we need to do is we need to identify the sample space for the experiment. For the experiment of tossing a pair of dice, we will have this sample space. So we know that number of elements in the sample space is equals to 36. After we have identified the sample space, the next thing to do is to identify the events. So there are two events here which are getting one of the dice equals to 2 and getting sum of the two dice equals to 6. So let's define A to be the first event, that is one of the dice is 2, and B to be the second event, that is the sum of the two dice is 6. From the sample space, we obtain the elements of A as well as the elements of B. So we know that number of elements in A is equals to 10 and number of elements in B is equals to 5. Now let's look at the question again. We want to find the probability that one of the dice is 2 if the sum of the two dice is 6. This means that we want to find the probability of A given B, which is a conditional probability. And we know that probability of A given B is equals to probability of A intersects B divided by probability of B. Since in the formula there is probability of A intersects B, we must first identify the intersection between A and B. From the sets of A and B, we obtain the elements of A intersects B. So we know that number of elements in A intersects B is equals to 2. Now going back to the probability that we want to find, the probability of A intersects B would be number of elements in A intersects B over number of elements in the sample space. The probability of B would be number of elements in B over number of elements in the sample space. Thus, we have 2 over 36 divided by 5 over 36, which makes the probability of A given B equals to 2 over 5. Now let's look at another example. For the experiment of throwing a die, we will have this sample space. So we know that number of elements in the sample space is equals to 6. Next, we need to identify the events. Here, there are two events which are getting an odd number and getting a prime number. So let's define A to be the first event, that is odd number, and B to be the second event, that is prime number. From the sample space, we obtain the elements of A as well as the elements of B. So we know that number of elements in A is equals to 3 and number of elements in B is also equal to 3. Now let's look at the question again. We want to find the probability that we get a prime number given that the number is an odd number. This means that we want to find the probability of B given A. And we know that probability of B given A is equals to probability of B intersects A divided by probability of A. Since in the formula there is probability of B intersects A, we must first identify the intersection between B and A. From the sets of A and B, we obtain the elements of B intersects A. So we know that number of elements in B intersects A is equals to 2. Please note that B intersects A is just the same as A intersects B. Now going back to the probability that we want to find, the probability of B intersects A would be number of elements in B intersects A over number of elements in the sample space, and the probability of A would be number of elements in A over number of elements in the sample space. Thus, we have 2 over 6 divided by 3 over 6, which makes the probability of B given A equals to 2 over 3. Now consider this example. In this example, because we are given with the information on number of people, it is wise to first label all the information that we have like this, so it will be easy for us to find all the probabilities. The first probability that we want to find is probability of unemployed, and probability of unemployed is equals to number of unemployed divided by number of elements in the sample space, which is equals to 300 divided by 900, and which can be simplified to 1 over 3. The second probability that we want to find is probability of employed, and probability of employed is equals to number of employed divided by number of elements in the sample space, which is equals to 600 divided by 900, and which can be simplified to 2 over 3. Next, we want to find the probability of male given employed. Because this is a conditional probability, we know that the formula for this probability is probability of male intersex employed divided by probability of employed. The probability of male intersex employed will be number of male intersex employed over number of elements in the sample space, while probability of employed would be number of employed over number of elements in the sample space. Thus, we have 460 over 900 divided by 600 over 900, which can be simplified to 23 over 30. Next, we want to find the probability of unemployed given male. Again, because this is a conditional probability, we know that the formula for this probability is probability of unemployed intersex male divided by probability of male. The probability of unemployed intersex male would be number of unemployed intersex male over number of elements in the sample space, while probability of male would be number of male over number of elements in the sample space. Thus, we have 40 over 900 divided by 500 over 900, which can be simplified to 2 over 25. This is the end of the lesson. You can try question E and F on your own. Just remember that the word if has the same meaning as the word given. Thank you.